Hello, my dear students. Welcome you all to Sri Jayendra Rank Zone classes. I'm your mentor and your friend for the subject chemistry, and I will be dealing with the organic chemistry. My dear students, as we have started methods of purification in the previous turn, we discussed about column chromatography. Today we are going to discuss about thin layer chromatography and then partition chromatography. So starting with this is what we have discussed in the last term, column chromatography. These are the chromatographic columns, okay, filled with the compound to be separated, okay, mixture of organic compound A, B, C, D, whatever it is, okay. It's a stopcock which basically helps to maintain the rate of flow of eluent, which is a what we can say, it's a solvent which is passed. Then it's a adsorbent which act as a stationary phase. Normally we use silica gel, okay, as a stationary phase, okay. Then the moment we pass the eluent, the organic compound which is loosely adsorbed, okay, or the extent of adsorption is very less for that particular component of the mixture, it will come into the solution, it will come into the eluent and will come downwards. So the moment it will come downwards, okay, it will get separated, okay, we will open the stopcock and the separation is done. In this way, fraction with second molecule, everything is separated. Okay. Now we are going to start with the thin layer chromatography. Okay. Thin layer chromatography or TLC, thin layer chromatography. Okay. It's another type of adsorption chromatography, you know. It's a type of adsorption chromatography only. Adsorption chromatography. Okay. It involves the separation of the substances. It involves the separation of the substances of a mixture over a thin layer of an adsorbent of a mixture over a thin layer of an adsorbent coated on the glass plate, coated on the glass plate. Okay, a thin layer around 0.2 millimeters thick of an adsorbent like silica gel or alumina Al2O3 is spread over a glass plate. Okay, so we take a glass plate, a glass slide, on which a 0.2 millimeter thick adsorbent is coated. That adsorbent is basically silica gel or alumina. Okay. Now this act as a stationary phase. The adsorbent we are coating, okay, on the glass plate, it will act as a stationary phase. Okay. That is why it is known as what, as we are using a glass plate, a chroma plate. That is why it is known as what, thin layer chromatography plate. The plate is known as chroma plate or thin layer chromatography plate. chromatography plate. Understood? Okay. The solution of the mixture to be separated. The solution of the mixture to be separated is applied as a small spot, is applied as a small spot, okay, 2 centimeter above one end of the TLC plate of thin layer chromatography plate. Okay, suppose this is the plate. Okay, so a sample spot of the organic mixture, solution of organic mixture. This is the sample spot. Okay, it is around 2 centimeter above from one end of the TLC plate. Understood? The glass plate is then placed in a closed chamber. The glass plate is enclosed in a jar containing an eluent, a solvent. Okay. As the solvent or the eluent rises up, the components of the mixture of the mixture move up up along with the eluent to different distances. Depending on their degree of adsorption. Of adsorption. And separation takes place. Okay. This is the plate. Okay. This is the solvent or the eluent or the moving phase. Okay. Silica gel is the adsorbent, that is the stationary phase. A baseline is drawn. This is the baseline, suppose, and this is the sample spot. Okay. As the eluent will move, okay, the components of the organic mixture as the eluent will move up. Okay, the eluent will carry the component according to their extent of adsorption. The one which is more adsorbed will stick to the chromatographic plate, and the one which is less adsorbed move with the eluent to a particular distance, and hence we get different components. Okay, the construction is very simple. We take a glass jar. Okay, this is the glass jar. Okay, the glass jar with the suitable eluent. We take the slide. We mark a baseline. Okay, and the spot, sample spot. The glass plate is coated with the adsorbent. Okay, now when the chromatogram is developed, it look like this is the baseline. This is the spot. This is distance x from the baseline. This is the solvent front. Solvent front is that maximum extent up to which the eluent or the moving phase or the solvent reaches to. Okay, solvent front. Okay, this distance from the baseline is y. So this x and y ratios will give us what? The retention factor. Okay, thin layer, the relative adsorption, thin layer chromatography. This is the chromatogram, developed chromatogram. Okay, now the relative adsorption of each component of the mixture expressed in terms of expressed in terms of its retention factor, that is RF value, right? The RF value is the distance moved by the substance from the baseline. Substance means the sample, the organic compound mixture. Okay, the substance from baseline upon the distance moved by the solvent from the baseline. Y. Okay. The spots of colored compounds are visible on TLC plate due to their original color. The spots of colorless compounds which are invisible to the eye but shows fluorescence can be detected by putting the plate can be detected by putting the plate under UV light. Under UV light. Another detection technique is to place the plate is to place the plate in a covered jar containing a few crystals of iodine, spots of the compounds. Okay. These spots absorb iodine, which absorb iodine, will show up as brown spots. Will show as brown spot, right? We have to place the plate in a covered jar containing a few crystals of iodine, spots of compounds, okay, which absorb iodine. Compound which absorb iodine will show a brown spot, okay. Sometimes an appropriate reagent may also be used, may also be sprayed on the plate. Okay. For example, amino acids may be detected by spraying the plate with ninhydrin solution. By spraying ninhydrin solution. Okay, this is all about the thin layer chromatography or TLC. Now, the partition chromatography. Okay, you can see the amino acid solution. Okay, and chloroform. Then there is a red dye. Okay, the glass tube is packed with grouped up with silica gel, wetted with water. Okay, series of colored bands form corresponding to different amino acids. We are basically differentiating amino acid, okay, which is in the solution with chloroform. Okay, now what is this partition chromatography? This is just an example of partition chromatography. The most common partition chromatography is the paper chromatography. Okay, so you can see it is based on the continuous differential partitioning based on continuous differential partitioning of components of mixture between stationary and mobile phases. Paper chromatography is a type of partition chromatography. Okay. In paper chromatography, a spatial quality paper known as chromatography paper is used. Chromatography paper contains water trapped in it. Water trapped in it, which act as the stationary phase. Okay. So chromatographic paper is used and contains water trapped in it, okay, which act as a stationary phase. A strip of chromatography paper spotted at the base, a sample spot is marked, okay, with the solution of the mixture. The spot is having basically a solution of mixture which is suspended in a particular solvent or a mixture of solvents. Suspended in a solvent or a mixture of solvents. Okay. The solvent will rise up, okay, rises up the paper by capillary action and flows over the spot. And flows over the spot. The paper selectively retains different components. The paper selectively retains different components of the mixture according to their differing partition. Components according to their differing partition. In the two phases. Okay, so the paper selectively retains the different components on the basis of their different capabilities, different extent of penetrating into or being a part of either of the two phases, whether it is a stationary phase or whether it is a moving phase. Understood? Okay. Now, the paper strip so developed is known as chromatogram, as you know. Okay. Known as chromatogram. Now, the one which is more deeply penetrated or want to be a part of more deeply want to be a part of stationary phase, they will they will it will stay there only, and the one which is more soluble in the moving phase, it will go with the moving phase. Okay, so it is the different partition mean being a part of the molecules, they will randomly move to the other phase. Okay, if they are not soluble or if they are more soluble in that particular phase. Okay, the spots of separated components separated colored compounds, the spots of the separated colored compounds are visible at different heights are visible at different heights from the position of initial spot from the position of initial spot on the chromatogram. On the chromatogram. The spots of the separated colorless compounds. Previously, we talked about the spots of the separated colored compound, which are visible at different heights from the position of the initial spot on the chromatogram. The spots of the separated colorless compounds may be observed either under UV light, okay, or by spraying any suitable reagent. Okay, my dear students, this is all about chromatography. Okay, in the next class, we will be starting with qualitative and quantitative analysis of organic compounds. Till then, bye bye, take care, stay safe, stay